All right, let's find the area of the segment to the nearest tenth. Recall that area of the segment is equal to the area of the sector minus area of the triangle. Let's first find the area of the sector. Well, area of the sector is pi r squared times m over 360. So we want to ask ourselves, what is the radius and what is the measure of the central angle or the measure of the intercepted arc, both of which are the same thing. So the radius is 7 centimeters and the measure of the central angle is 100 degrees. So the area of the sector is pi times 7 squared times 100 over 360, which is going to be 245 times pi over 18. We'll round this to the nearest tenth at the end, so we'll get the exact answer and the rounded answer. Up next, we need to find the area of that triangle. Area of the triangle is 1/2 base times height. So let's draw in our altitude. That is going to be our height. All right, so there you see that. Now think about what the altitude does to the side of the triangle it intersects. The perpendicular segment from the center to a chord bisects the chord. Okay, we're going to end up with two segments that are congruent to each other. That's going to come in handy because we're going to find the length of half of this right here. And then we'll, so say we get 8, it'll be 8 and 8. So the entire chord, which is going to serve as the base of this triangle, is going to be 16. That is not me saying that the base is definitely 16. That was just an example. Now, this altitude is going to bisect this vertex angle up here. Here's why. This leg is congruent to itself, the reflexive property. We have a 90-degree angle, right? I can draw it in the perpendicular segment. And also the hypotenuse is 7, and it's congruent to that hypotenuse is 7. So we have two congruent triangles through hypotenuse legs. So we do have angle measures of 50 and 50. So what I want to find is two things. One, I want to find my height, the altitude here. And I want to find this opposite side here, which is going to be half of the base, which is half of this chord, right? So I do know that my radius is 7, so let's fill that in. And pause for a second here. We have a right triangle where we know one of the angles and one of the sides, and we need to find the third side, or back up, need to find another side, right? So we can't use the Pythagorean theorem, but we can use trigonometry. So let's find this opposite side first. That's going to be half of the base. So opposite and hypotenuse is going to be sine. So when I multiply by 7 on both sides, 7 times sine 50 gives me, and we're going to have to round now. So let's call it 5.4 when we round to the nearest 10. So x is equal to 5.4. That's going to be half of our base. Probably better to take it out to the 100th actually, because it's 5.36, but I wouldn't fault you either way. So when we double 5.4, notice in our image here, 5.4 and 5.4, that gives us a base of 10.8. If you round it to the nearest 100th, you would have had a base of 10.7, but either way is fine. All right, so now to find the altitude, the height of this triangle, again, we're going to use trigonometry, the adjacent side and the hypotenuse. So that's going to be cosine. And when we multiply by 7 on both sides, right, cosine 50 equals adjacent over hypotenuse. So we multiply by 7 on both sides, 7 times cosine 50. Make sure you're in degree mode. I didn't mention that earlier, but you should be. We get 4.5 for the altitude, 4.5. So we have a base of 10.8, we have a height of 4.5. We can find the area of that triangle. Area of a triangle is 1/2 base times height. So we get area of the triangle is 1/2 times 10.8 times 4.5. And the area of that triangle is 24.3. So now to find the area of the segment, we have to subtract the sector and the triangle. So let's do that now. So the area of our sector, 245 pi divided by 18, that comes out to be about 42.8 when you round to the nearest tenth. So 42.8 minus 24.3 gives us 18.5. What are our units going to be? Centimeters squared, because we are finding area. There you go, 18.5 centimeters squared.